Hello and welcome everyone. I hope you guys are doing pretty amazing and we will see today's daily challenge on Leetcode and try to solve it together. So let's see the problem and try to understand in detail that what it wants to say to us. Okay, so special binary string. Uh, so it is first of all, there is a definition which is given for this special binary strings. They are the binary strings with the following two properties. The number of zeros is equals to the number of one in that string, and every prefix of the binary string has at least as many ones as zeros. Okay, at least as many ones as zeros. So at most as many. I mean, all ones can also be there. So it just wants you to say that every prefix of a binary string which we are considering. So it just wants you to say that if you are considering any binary string, every prefix of that string should contain more or equal number of ones. So if you see, uh, let's say for this string, this prefix has three ones. So that is fine. This prefix has four ones and one zero. Okay. This prefix has four ones and two zeros. This prefix has four ones and three zeros. Even this is fine. But something like this won't be fine. Let's say 1 0 1, something like this. Okay, although as a whole the string has three zeros and three ones, right? Both are three, but you see, if you consider this prefix, it has two zeros and one. Okay, so the number of zeros are more, so this whole string is cannot be special. Okay, so any prefix of the string should have an equal number of zeros and ones. That is true for the whole substring, but all the prefix should have at least as many ones as zeros. So at least as many ones as zeros, so it means that the number of ones should be greater than or equals to the number of zeros in every prefix of the special binary string. Okay, and you are given a special binary string s, so the input of the string will always be special, it is told to you. Okay, and move consists of choosing two consecutive non-empty special substrings of s and swapping them. Okay, and two strings are consecutive if the last you know the meaning of consecutive, right? So in one move, it is defined that you choose two consecutive non-empty special substrings of S. So you see one thing. S was itself special, and you want to find special substrings of S. Okay. You want to find the special substrings of S which are consecutive, non-empty definitely, and you want to swap both of them. Okay. And you want to return the lexicographically largest resulting string possible after applying these moves as many number of times. Okay, so after applying the mentioned operations on the string. Okay, so let's try to see what all things can be possible. Okay, so first of all, in order to not get confused and all, you can think it something like uh, some binary sequences there, 1 1 0 0 1 0 and some things like that. Okay, and so let's not take this substring, let's take this one, 1 0 1 1 0 0. Okay, and what you can think it of, like whenever you are encountering a one, you are increasing yourself. Okay, you are increasing yourself, and when you are encountering a zero, you are decreasing yourself. So in the whole string, the number of times you will increase yourself will be equal to the number of times you will decrease yourself. That is, the number of ones will be equal to zeros, so you will meet back at the same number line. Okay, in the if you consider this as a number line base, you will meet at the same base again. Okay, so yeah, I hope that is very clear. And let's see. You can try to imagine it in this way. If you are fine with the analogy of zero and one, that is also very correct. And if you try to draw this whole thing, you see, you go one again, you go one again, you go zero, zero. So it's like it's 1 0 1 1 0 0. Okay. So I hope this is very clear. And you want, so what did you understand from this? You understood something like this whole thing is one mountain and this whole thing is another mountain. Okay, and both of them are special. Okay, so from this some properties you can definitely say that, hey, you can never go below this number line. So let's say here is a number line and you want to you get 1 and 0, and then again you are getting 0. It means that you are going below the number line, so this is not possible. And you should always start with a 1. You should always start with a 1. So if you start with a 0, at first only you are going down, okay? And you see, at the end you need to reach this. At the end you need to reach this, and you must reach this from the top. Okay, you must reach this from the top. You cannot reach the number line at the end. The When you are completing one mountain, you cannot reach it from the bottom, because you are not never allowed to go to the bottom, right? So one thing is very sure, that at the first, since there should always be an increment, there should be 1 at the first, and at the end there should be 0. So the thing which I want to make point is that one property you can just tell, okay, we will use this property later. One property of this special substring, you can tell that it starts with 1 always. It starts with 1 always, okay, and it ends with 0. Ends with 0, okay. uh, and if it contains equal number of zeros and ones, and every prefix has more ones than zeros, we will call it a special substring. That is fine, but those properties give you this constraint definitely. This should definitely happen, okay? So just keep it in your mind, okay? So now returning back to our discussion, yeah, you do realize that even this 1 0, since no part of the mountain is below the number line and no part, and both are meeting in the number line, this 1 0 and 1 1 0 0 both are special substrings. Both are special substrings. And as a whole, this substring is also special because, again, both are meeting at this point. I mean, starting with 1 and ending with 0, and you have an equal number of zeros and ones, and you are never going below the number line. So this is valid. As a whole, this substring is also special, no doubt about that. Now, a move, it is told that you need to perform a move. Okay, so now you want to swap these two, right? Because you see, lexicographically largest means it has 1 1 at the beginning, right? So, and this number is also greater, right? So if you consider this as two strings, 1 0 string and 1 1 0 0 string, you can choose to swap these two. So this will become first, so it will have something like this. Okay, and yeah, I hope that is clear, that you if you encounter something like this, you can swap it. Now, now you can tell me, hey, something is coming to my mind, and I am getting a something very clear idea. Okay, so let's see this mountain, let's call it M1. This mountain, let's call it M2. Okay, so are these the only mountains that you are gonna get? You can get many more mountains, right? M1, M2, let's call M3, and some so on. There are more mountains. Some shape may be like this, and it may be anything, right? So you might get more mountains, okay? And you can just tell me that, hey, this mountain, all the mountains, if I just extract those, okay, and store them in a vector of string. See, this is a string, this is a string, and so I will store all the mountains in a vector of string. Let's say there are k mountains, and I will reverse sort this string. So if you know, if you sort a string, it by default it takes the lexicographical order. So if you want to take the largest lexicographical order first, so you can just reverse sort the string, okay? So reverse sort this vector of string, okay? I hope the approach or the idea is very clear. And you can tell me, hey, why don't we do that then? I will tell that, hey, definitely you will do this, but there can be some more cases. There can be some more cases. See, what did we consider? What did we consider? We considered something like uh, 1 0 and 1 1 0 0. This as a whole, we consider it as a string. Now consider that this whole string is wrapped in some more strings, right? So let's say I'm putting 1 at first and 0 at the beginning, okay? To make it something like this, okay? Now I'm telling you that if I give you this input string, try to draw the mountain. How it will look like? So try to draw it on your own. See, you will get 1, then again 1, okay? Then again 0 you are having, then again 1, then again 1, Okay, then again 0, 0, 0. Okay, so you see, how many mountains did you get? You got only one mountain, right? Because you are having this. Considering the base as this, you are having only one mountain M1. Now you will might say that, hey, there is nothing to sort, so this is the answer. No, this is not the answer. Why? Because you you do understand what I'm trying, right? Telling, right? I told you to store those mountains of strings in a vector and reverse sort them, okay? To get the lexicographical order, and you just get the string, final string. So by concatenating all of them. But you say that, hey, this is not true because this is a substring and this is a substring. So considering the base of the mountain is shiftable, considering the base of the mountain is shiftable, I may have more mountains inside. This might be sub, let's say M1 dash or M2 dash, and I want to sort them also because this and this, you can just swap both of them, okay? You can just swap both of them. So so the thing is that the initial array which you form M1, M2, M3 dot dot Mk, they also, each of the mountains may have some sub mountains. Let's say M2 has some sub mountains within it, M21 or M22, something like that, or M2k dash. Okay, so I hope you do understand, and you need to sort them also. You need to reverse sort them also. So here comes the idea of the recursive fashion. So you need to do it in a recursive manner. Okay, so this whole thing which I told you, you can just do it in a recursive manner and you will get your answer. Okay, you will get your answer to be very correct. So let's try to see the code and everything will become very clear. I hope you at least understood the intuition of what all are the things we need to do. And yeah, that is all. Yeah, you need to just reverse sort it and at the end concatenate it. But this, you need to do this recursively because inside one mountain there can be many more mountains, right? And you need to make them arranged also. Okay, I hope you do realize why we are sorting and stuff like that, because yeah, by some amount of swaps, by swapping continuously one mountain, you can sort the whole array. Okay? And you need a recursively largest string. So yeah, you need to reverse sort the whole array. So lexicographically largest. Yeah. So let's see. Let's see. Try to have some things. Okay. At first we have this string integer n. Okay. Let's keep a L pointer, left pointer, left side of the mountain. So we will iterate through the mountain, and let's say keep a balance also, right? Why balance? I will keep a variable, let's say balance. Okay, I will call it balance or anything you can call it. It will start with 0, and if there is 1, I will increment balance plus plus. Okay, and if it's 0, I will decrement this balance minus minus. So it will simply mean that when balance is 0, so this balance is 1 now, this balance is 0 now. So when balance is 0, I have got one mountain. Okay, when balance is 0, I have got one mountain. So at these points the balance will become 0, and in all those points I will get a mountain. So yeah, int balance equals to 0. So I hope this is very clear. Int r, I will take r, and yeah, I told you about this vector of strings. Okay, this will contain the mountains. Okay, I'm calling those blocks. Okay, so this will contains the string of mountains. Okay, so now we have this r less than n, r plus plus. Okay, so one thing is very clear, that if you encounter, so in this iterating variable, if you encounter something as 1, then simply increment your balance pointer counter. Okay, plus plus. Else you can just simply decrement that. Okay, so once you have that, you can tell me, hey, when I have got balance as 0, when I have got balance as 0, I can, what I can do, uh, found a mountain. Okay, you can tell that I have found a mountain, so uh, I will do some things. Now, as I told you, see, remember, mountain always starts with a 1 and ends with a 0. So let's say you have found this mountain. Okay, you have found this mountain, right? You want to pass this whole thing recursively. So at first the 1 and the second 0, you want to neglect it and pass the remaining thing as the uh, recursive variable, right? So string inner, I will call a string inner, and I will use a substring function to extract the substring. So s dot substr. So I hope you know how this function works. At the first argument, it takes the starting index. Okay, so starting index will be l plus 1. Okay, plus 1. Why? Because I'm at the l right now. So if this is the l, I want to start from l plus 1. Okay, and I want to go till some length. Okay, so the second argument is how many length I want to traverse. So let's see how to calculate that. So if you have the 1 and 0, you have 0 length, because you see this is the mountain and you have nothing in between, right? If you have something like this, 1 1 0 0, so you might have these two, right? So if this is l, okay, this is r. So if L minus R, so L minus R minus L, this R minus L value is, if it is 1, then you have nothing, you have 0, right? And if there is something in between, so that will be R minus L. See here, R minus L is 3, right? Minus 1, but here two length string is there. So you do minus 1. So the second argument, since it takes the length, you just take R minus L minus 1. Okay, I hope it is very clear. So yeah, I am just passing the inner things. This is just for the recursive purpose, and I want to just simply calculate in a recursive fashion and insert into the block. So I can do something like make largest special. Okay, and I have this inner variable which I will pass. Okay, and in order to get the string directly which I want to insert into the block, what I can do is have this 0 and have this 1. Okay, I am just concatenating this and just telling that, hey, you can insert it into the block. So blocks dot pushback. I hope this is correct. Uh, So this is the inner block which I just passed up in a recursive manner. Okay, I just want to check if there are more mountains inside my mountain, and this is the starting and the ending point. This as a whole, this as a whole is also a mountain, so I want to push back into my block. Okay, so yeah, I hope this is very clear. And you just see your L pointer starts with 0, so you just want to have it updated to R plus 1. Okay, so and after all this, you want to have your final answer. So final answer is not a vector of string, but it is a string itself, right? So you can just concatenate all of the strings. So you can just iterate for auto B blocks. Okay, and just answer plus equals to B. You concatenate all of your answers into your B. Okay, and you see, you want to reverse sort them also, right? These blocks, you definitely want to reverse sort them. So sort blocks dot r begin and sort blocks dot r end. Okay, you want to reverse sort them, and you just simply return your answer right now. Okay, and if you tell me that, hey, you are making this as a recursive function, where is the base case? Okay, this is a valid question to ask, but you see, the base case happens when this is an empty string, right? You get this 1 and 0, and in between you have nothing. So by doing substring, you get an empty string. And if you pass up an empty string over here, you see this block will be empty, the size will be 0, and there will be no loop over here, right? There will be nothing to sort in the block, and it will return an empty string itself. Okay, so yeah, if you pass an empty string, if you pass 1 0, right? Okay, if you pass 1 0 only in this string, you get an empty string over here. You get an empty string over here, and at the end, nothing will be returned. So that this is only the base case of the recursion which it handles correctly. Okay, so yeah, that is all we need to do for this problem. Let's try to run and check if we did any mistake in between. Okay, so let's do some debugging. We have block and blocks here. So let's see now. So yeah, we do have the accepted thing for these two cases. Let's try to submit it for all cases and see. Yeah, so we do have the accepted thing. I hope the solution was very clear to you. And if you are having any doubts still, you can definitely ask me in the comments. I hope this is very clear at least. So yeah, that's all. That's all for this video. I will meet you in the next video. Till then, thanks a lot.